Yes, we are recording. Before going to the PowerPoint, and first let's have a prayer, but then before going to the PowerPoint, I want to go over some of the question on the quiz and the assignment. Let's have a prayer. Father God, I thank you that you have blessed us with another module, another session of learning and studying and becoming more prepared servant for your glory, for service of your church, for the gospel. Even in this course, even in math, may it be that we see the wisdom and the power and the beauty of our God. I pray for all the students in this class that they may do excellent, not only in math, but also in other courses that they are taking. And your name be glorified in our lives. Thank you again. We commit tonight, this session, into your hand. In Jesus' name we pray. Amen. Amen. Right, as I said, before we go to our lesson for tonight, there are a few things I wanted to go over from the quiz and the assignment. Let's first, you probably, I don't remember, you probably didn't have this problem, but some other student did. So on the quiz, question number 7. First. We want to find x in 7 plus 5, x minus 4, the power of 3, where x is equal to 6. We want to solve this function actually. All right. So we plug 6 into x. You have 7 plus 5, 6 minus 4 to the power of 3. So we have 7 plus 5. First, we simplify inside the parentheses. 6 minus 4 is 2 to the power of 3. And that is again equal to 7 plus 5 times 2 to the power of 3 is 8. So this is 7 plus 5 times 8, 40. So then it says 47. Okay? Clear? Yeah, I didn't think you had a problem, but some other student did. So I want to try to go over that. Question number 10. Question number 10, it says use the FOIL method to multiply these two parentheses, 3x plus 4, 5x times parentheses 5x minus 3. So basically is, we take this term, 3x multiplied by here, utter by utter, then utter by the inner. By this one. 3x times 5x is 15x2. Right? 3x times minus 3 is minus 9x. Then we take 4 multiplied by this term, and then we add. So 4 times 5x would be plus, or they'll go positive, so plus 20x. 4 times minus 3 is 12. So then we simplify this, we get 15x to the power of 2. We have minus 9x plus 20x becomes plus 11x minus 12. That's it. Okay. And another question that I noticed some students missed was question number 11. It says, what is the slope of the line represented by 10x minus 5y equal to 10? Okay, you remember the basic formula for slope of a line was y is equal to mx plus e. Yeah? And what's the slope in this equation? M.
That's the slope.
Yeah. So we need to make that equation to change it to this form. So, and what was the definition of a slope? It's a rise over run. It shows what's the how high or in what degree a line is going up or is going down, depending on whether the slope is plus or negative. So I want to change this into that shape. I need to get rid of this 10x here. Subtract both sides 10x. These two cancels. So I get minus 5y equal to 10 minus 10x. Then I need to get rid of this minus 5 because there is no number over there. There's no coefficient over there. So I divide both sides by minus 5. So I get these two cancels. So I get y is equal to, same as y is equal to, so I get 10 over minus 5 and minus 10x over, or actually let's put it plus, minus 10x over minus 5. Yes? You follow that? So then y is equal to minus 10 divided by minus 5 is plus 2x. 10 divided by minus 5 is minus 2. So when you compare these two equations, what is n?
2 plus 2.
Yeah, plus 2. That's a slope. So you just have to bring that into that form and find the slope. Okay.
Just one question. I knew the slope. I didn't remember what was p. What was p stand for?
The p,
yes.
P is just some kind of number, some constant. That's all. So you want to change it so that this would be just a number, no x or any other variable.
Okay, okay.
Just a constant.
Okay.
Okay. Let's have this for a while. All right. Then let's go to our lesson for tonight from PowerPoint, which is on geometry. So I think everybody can see these. Now I have to change that to share a screen. Okay. No, what happened? Okay, yeah, nice. People can see that. Let's make it into. Okay, all right. I believe you had geometry in high school. Mm-hmm. So how did you like it? Okay, good. And it's fun, and it's not that difficult at all. Much easier than algebra, but yeah, I believe algebra is fun too and easy once you understand it, the basic principle. We want to talk about points, lines, planes, and angles, and different geometrical shape. Point, you can see that it just has 0 dimension. It's just a dot, and a symbol is a capital letter. Line segment is a part of a line, but it has has endpoints on both ends, and it's represented by capital, by those two endpoints, like AB and just a bar at the top. Ray is actually like a line that has one endpoint, but it continues in the other direction. In physics, that ray is called vector. Yeah, an exact representation. AB with an arrow at the top. Again, a line is just a bunch of dots next to each other that they can go in both directions infinitely. All right. So we want to talk about points, lines, planes, and angles. And you have these are planes that you have right down here, different shapes, intersection of planes, and all that. Let's continue. I don't see anything. Funny. Okay. What we are going to learn is how to identify and model points, lines, and planes, and how to identify collinear and coplanar points and intersecting lines and planes in space. Point is just like a dot, a location represented by a capital letter or a small dot, has no size, no length, no width or thickness. Let me make this smaller. That's part of the problem. Please follow on your PowerPoint. Point is simply a location. You draw it with a dot. We name it with a capital letter and has no dimension. So we say point P if you want to use words. Line, a series of points that extend in both opposite directions without ends. And we name it AB with an arrow that has flashes on both sides at the top, or line M. But if you want to use a word, it has to be a small letter. That's just a convention. Line is made of points, draw it with arrow on both sides. If we can identify 2 points on any line, then we can call that line with those 2 points. Like here, this line, you can either call it N, small letter N, or line AB or BA with a 2-sided arrow at the top. And these 2 points, A and B, are called collinear because they are on the same line. For example, when we look at these lines, points A, C, and B are collinear, but not D on line N. For example, example 1, are these 3-point collinear? If so, name the line on which they lie. For example, we have A, then we have D. Yeah, that's point. Let's see. Yeah, point D and E. Where is E here? No, A and E are collinear, but not D. Or B and C and D. B is here, but C is supposed to be this intersection. So they are not collinear, and D is not. If there was a line going through B and D, we would say B and D are collinear. A, E, point A, point E, and point C. Yes, we are on line M. Okay. Line M can be called by, like EA or AGCE or ECGA. Doesn't matter. Okay. Plane, it's a flat surface, has no thickness, contains many lines, and extends without end in the direction of all the lines. Its name is either by a single capital letter or by at least three non-coplanar points. The page, for example, in a book resembles a plane, but it's not an actual plane because it does have a thickness and it doesn't go, it doesn't extend indefinitely. For example, here we have a plane, and I made a correction on the PowerPoint. This should be, we have coplanar points, A, C, and T. They are in the same plane, so they are called coplanar. Okay. We call it with a capital cursive, or you can call it using three non-collinear. They are non-collinear. They are not on the same line, but they are coplanar. Do you see the difference? Yeah. A, C, and T are not on the same line, but they are on the same plane. Yeah. So we can call plane B also chat, or chat, or catch, or whatever, or ACT, whatever. Coplanar points and lines that lie in the same plane are called coplanar. These are coplanar, but not this one. Like these two are not coplanar, that intersect that plane. Now, I know this is a little bit tricky. Let me, we are on PowerPoint 14. The trickiness has to do with the visualization. You got to let your eyes get used to it. The front side is DHTI. That's plane N. Okay? Can you see that? Okay. You see, this plane, this side is represented by DHTI.
Oh, okay.
Okay. Now, this side is HART. That side, would be left side, is DMNI. And the back is MNRA. So I say just kind of got to let your eyes capture these plane. It's a little bit problem with visualization because we're trying to visualize a three-dimensional picture in a two-dimensional surface. Okay, here this one is better, it's clearer. For example, you have the front is DHTI, the back is M. Again, it depends. Like for a moment, my eyes just goes back and forth. For me, was in the beginning the front was DHTI, but if you look at it, then it goes back in your mind. The back is MNRA. The side on the right is HART, and the side on the left is DMNI. But if you kind of stare at it, then I can see the front as MNRA. It goes back and forth. But I put this bold to specify that this is the front, DMTI. Okay? Right angle is just when it's 90 degrees, 1/4 of complete rotation. Acute angle is less than 90, obtuse angle is more than 90 but less than 180. 180 angles is called, two angles that measure sum up to 180 is called supplementary. Straight angle is 180 degrees. Complementary angles are two angles, when you add them up, you get 90. Just have to memorize this. Like here, yeah, you can see them. For example, in we are on PowerPoint slide number 17, you can see we have a This one, angle or in degrees. For example, this one is ABC, this one, and this is 45 degrees. So this is a, what kind of angle? Acute. This one, what kind of angle is this one? Obtuse. Yeah. But not 180. This is what kind of angle? Right angle, 90. This is a straight angle, 180. This is, no. If you have this kind of angle, the other side will be the reflex angle. Okay. These two are complementary because if you add them up, you get 180. And again, these two are also complementary. These are complement. That's supplementary angle. I'm sorry. This is a complementary angle. When you add them, you get 90 degree. When you add these two at the top, you get 108. Okay. Parallel lines are lines that go, unless they do not intersect, they don't have any common points. If two different lines in the same plane are not parallel, then they intersect and they have a point in common. That point is called intersecting lines. If the lines intersect at an angle of 90 degrees, then they are called perpendicular lines, or we can have perpendicular planes. If we intersect, if you have two parallel lines and intersect them with another line, that line is called transversal, and it produces, then we will have 8 different angles, like as you can see on slide number 19. We have line A, line M. They are parallel. They don't have any points in common. Line T cuts through both of them. It's a transversal line, and it produces 8 different angles. Okay. The key to remember, the angles that are just opposite of one another are equal. Angle number 1 is equal to angle number 4. 5 is equal to 8. 6 equal to 7. Also, 1 is equal to 5. And that helps in lots of exercises. Okay, then we have triangle. In a triangle, it has 3 sides. You have interior angles, and then you have exterior ones. Okay, then we have different types. Basically, we have 3 types of triangles. We can divide the types of triangles based upon their angles or their sides. You see, this is called an acute triangle because all the angles are measured, each of them are less than 90 degrees. This is called a right triangle because it has one angle 90 degrees. This one is called obtuse triangle because it has one angle more than 90, okay? Now, you can also have angles, divide angles based on their side, their side. If, for example, if you have a, if you have an angle that all 3 sides are equal, and then you will have 3 all the angles have same degree, then you have equilateral triangle. If you have no sides or angles are equal, then you have a scaling triangle. If you have 2 sides equal and therefore 2 angles, these 2 angles are equal, then you have isosceles triangle. Okay? Let's look at example 1 and 2 on page 541. Page 541. Yeah. On example 1 and 2 on page 541, example 1, for example, it gives us that figure 10.16 and says find the measure of angle A. So the sum of the angles of all triangles adds up to what? 180 degrees. So we have angle number B, we have angle C. B is 120 degrees, C is 17 degrees. We want to find A. So angle A plus 120 degrees plus 17 should be 180. We solve that for A should be 43. Okay. Example number 2, find the measures of the angles 1 through 5 in figure 1017. Okay, what is the angle number 1? Just by looking at that figure. 90 degree. Then we have angles number 1 is 90. We have that angle at the bottom is 43. The plus angle number 2, which we don't know, they should add up to 180. Okay. When we do that, we find angle number 2 is 47. Therefore, number 3 is what? 47 degree 2. Then I have 47. I have 60 degree. Then I can find angle number 4. And angle number 4 is 73 degree. Okay? Now, if I have angle number 4, 73 degree, how can I find number 5? Yeah, because that total angle is 180. So you just subtract it from 180 is 107. That's how you can find these angles. Okay. Similar triangle are triangles that corresponding angles have the same measure and ratio of the lengths of the corresponding sides are equal. For example, if you look at figure 10.18, page 543, these are similar triangles, because you find the corresponding angle have the same measure and the ratio of the sides are also the same. In other words, 6 side AC over DF is 6 over 3 is equal to 2. Side CB over FE is 8 over 4 is 2. So you see the ratios are equal, not the size, but the ratio. Okay. Again, side AB over DE, 4 over 2 is 2. So then we can say the corresponding angle B is equal to E, angle C is equal to F, angle A is equal to D. So look at, for example, example 3. It says, explain why the triangles in 10.19 are similar. Because when we find a ratio, for example, the side, let's look at it. Shows that the two angles of the small triangle are equal. These two angles are equal, and when they intersect, the point that they are connected, the vertical angle have the same measure, so these two angles are equal. And the pictures, you see that sign, that little bar that you see on the angles at the two ends, that means they are the same degree. So if these two, those vertical angles where the sides, are connected, are equal, and those two other angles are equal, the third angles are equal. Therefore, all the angles are equal. Therefore, these two are similar triangle. Now, we want to find x. How can we find x? The ratio of the sides are equal. 5 over 8 would be same as 7 over x. Are you following me? Any question? Okay. Therefore, if you solve that for x is 11.2. And, so to solve it for x, just simple thing to do. Multiply each, the bottom and the lower of each side by each other. In other words, 5x is equal 8.7. On the other page, on page 544, at the top, it shows that A over B equal to C over D is the same as AD equal to BC. So we have 5x times x equal to 8.7, 5x is equal to 56, x is 11.2. All right? Okay, these are very helpful. For example, on example number 4, we want to find the height of the lamppost. The guy who's standing in front of it is 6 feet. He's standing 10 feet from the lamppost, and his shadow is 4 more feet in front of it. So we know again that these two are, they can form a similar triangle because they have one angle in common, and they both have two right angle. Yes? Yes. So the third one must be the same. Therefore, they are similar triangle. Therefore, the ratio of the sides are the same. Therefore, we can say 6, the size of the height of that guy, over or x, the height of the lamppost, over the side, the height of the guy, x over 6 is equal to 14 over 4, and we solve it for x. We find the height of the lamppost. Another example, if you look at example 6, on page 545, we want to construct a vulture ramp. The length of the ramp itself is 122 inches. The distance from the door till when it actually touches the flat surface is 120 inches. We want to see how high the ramp should go. Okay? So again, what we do here is actually this I'm going ahead of myself. We are using Pythagorean theorem. I explain it here, but we are going ahead. This is from another part of the lesson. But basically, it says that the angle in front of the the side in front of the right angle, C, C square is equal to sum of A square plus B square. So when we plug in those values, we have the C square, and we have one of the side. We square it and solve it for x. We find how high should be the slope of that ramp. Follow me? Okay. Yeah, I went ahead of myself on that. Actually, we are going to, Pythagorean theorem. The sum of the squares of the length of the legs of a right triangle is equal to the square of the length of the hypotenuse. Hypotenuse is that side in front of the right triangle. Okay, so in that blue triangle, as you can see on slide number 23, what's the hypotenuse?
Well,
5.
Orange, yeah.
Yeah, 5. And these two are the legs, 4 and 3 and 5. So if you square 4, 16, square 19, 3 is 9, add them up, you get 25, which is a square of hypotenuse. So, and that's how we solve that example of the ramp. For any right triangle with the sides A and B and hypotenuse H, the square of the hypotenuse is equal to the sum of the squares of the two sides. Well, we did 545 already. Let's see, example. Well, actually, let's do example 5. We did example 6. In example 5, page 545, you have that triangle. It's a right triangle. The side C is the hypotenuse. We want to find that. We have the two legs or the two other sides, 9 and 12. C square is equal A square plus B square. C square is equal to 9 to the power of 2 plus 12 to the power of 2. We add them up. We get 225. The square root of 225 is 50. So that hypotenuse is 50. And we already did number 6. That again, in number 6, if you look at figure 10.27 on page 546, you have a right triangle. And we have the hypotenuse this time is 122 inches, and we have one of the legs 120 inches. We want to see how high, what's the slope? Here's a slope. What's the slope of this ramp? We want to find x. So we know 122 to the power of 2 is equal to x squared plus 120 to the power of 2. And we just solved it for x. We got 22. All right? Yeah. Then also we have shapes, polygons, perimeters, tessellations. Shapes can have same area but different perimeters. Shape can have same perimeter but different areas. Just have to keep that in mind. And, you know, we can have two shapes, same perimeter but different areas. Okay. Let's look at example 1 on page 551. Okay, it says we have a rectangular field, discussed previously, has a length of 42 yards and a width of 28 yards. They want to put a fence around it. If fencing costs $5.25 per foot, find the cost to enclose the whole field. Okay, so first we find the perimeter. Is a rectangular shape. So we have 2 length and 2 width. And length and the width they have already been given to us. So we multiply 2 by the length and 2 by the width and add it up, we get 140 yards. We want to convert that to feet, and remember the rule. Whatever you want to be the final result, that should be in the numerator, and what we want to get rid of should be in the denominator. 1 yard is equal to 3 feet. The yard should go in the denominator. The 3 feet should go to the numerator. We get 140 yards multiplied by 3 feet over 1 yard. We get 420 feet. And it says per feet it costs $5.25. Then you multiply by 525, you get the price, $2,205.
Wow.
Okay. We have logged in from another device. All right. Okay. Let's move on. We have polygons. Whenever you have an enclosed shape in a plane formed by 3 or more line segments that intersect only at their endpoints, then you get polygons. You have, you get shape on a plane. You need to have at least 3 lines, like a triangle. You can have more, but at least 3 that intersect only at their endpoints. Then you end up with a polygon. Triangle, trapezoid, pentagon, rectangle. Okay. We have quadrilateral shapes. Just remember to know these terms. Let me make it a little bit bigger for myself. We have trapezoid, you have one pair of parallel lines. We have no parallel sides. It's called quadrilateral. We have two pair of parallel lines, parallel sides, like these two, and these two are parallel. So we get parallelogram. Okay. We get rectangle, congruent angles. They're all 90, 90, 90. But the sides are, two sides are equal, and the two sides, the lengths and the widths are equal. Square, all the sides and all the angles are equal, 90 degrees. And when you get parallelogram with congruent side, then you end up with rhombus. The sides are equal to the difference between these two. It's a rhombus is a parallelogram that the sides are equal. See, that's this one, the sides are not equal. These two are equal, but not these. This is not equal to that.
Okay.
Yeah, but in a rhombus, this one, all it's like a square. You just tilt it.
Okay.
Yeah. All right. Sure. Yeah, I think this is not much. 10.3. You just have to identify what these are. I don't think there's much here. Tessellation of a flat surface is tiling of a plane using one or more geometric shape. You see this? You have like tile that you put in a bathroom, in a kitchen, or whatever. You just have geometric shape that keep repeating themselves. Arrangement of shape closely fitted. This is basically how you can see the practical application of geometry in engineering, okay, on construction. What is a tessellation? A repeating shape that covers a surface without overlapping or leaving gaps. The word tessellation comes from the Latin word tessera, which means a small stone cube. But it doesn't have to be cube. It can be any shape. And the earliest tessellation were found in mosaic pictures on the floor of old Roman buildings. Okay. Like this one. See, they're all different. And in math, tessellation can be even generalized to higher dimension. It doesn't have to be only 2 dimension. They can go to 3 dimensions, as you can see here.
Like the honeycomb?
Yep, exactly. Metamorphosis. You see, it starts from here and changes to something else. All right, areas, circumferences. Basically, let me make this bigger for me. So I will give you these formula, but it helps to know some of them. Triangles, the area, you add up the side. For the circumference, I'm sorry, the area is base times half of the height, or base times height divided by 2. Rectangle, rectangle, the area is width times length. For a square, all sides are equal, so one side to power of 2. For a circle, the area is the number pi times radius to power of 2. Circumference is 2 pi r. Okay, I give you this formula, so if you memorize them, it's good, but if you didn't, that's okay too. All right. Rhombus, rectangles, squares, parallelogram. Any question?
What the limit or circumference of the circle?
Circumference is 2 pi r. The number pi times the radius times 2, or diameter, because 2 times radius is diameter.
Okay.
Pi times d. Okay?
Yeah.
Right. Let's maybe do some of this here on page 558. Now we have done this before, I believe, but let's look at it again. Example 1 at the bottom of page 558. You decide to cover the pad to solve the area problem. You want to find this whole area that is presented to us in figure 10.37. We have, one side you have 13 feet. The other side you see that the bottom 3 feet. So what's that larger side at the top? 13 plus 3, 16 feet. Okay, now look at this right side. We have 6 feet. They look like 2 rectangles.
Yes.
That are connected. So up to the point, it's 6 feet. The rest is 3 feet. So that whole thing is 9 feet. So we have all the side. We can actually divide this into 2 rectangles and solve the problem for ourselves. So the area would be length of that top rectangle. The length is 16 feet times 3 feet. Okay, is 48. The smaller rectangle, the length is 6 feet times 3, 18. So 48 feet square plus 18 feet square, we add them up and we get the final result, 66 feet, okay? Now, if the pad requires 4 breaks for every foot, how many breaks are needed? It continues. So again, what you want to have as your final result goes to the numerator. What you want to get rid of goes to the denominator. It says for every square feet, it needs 4 breaks. So we put the square feet at the bottom in the denominator and 4 breaks at the top. So we end up with 66 times 4. So we need 264 breaks. Okay. All right. Okay, let's see. Example 2, solving area problem. What will cost to carpet a rectangular floor measuring 12 feet by 15 feet if the carpet costs $18.50 per square yard? Again, we must convert this the measurement we have in feet to yard. We want the final result to be in yards, so the yard goes at the top. In the numerator, the feet goes to the bottom, to the denominator. 1 yard over 3 feet. So we multiply the 12 feet by 1 over 3, we get 4 yards, and we multiply 15 by 1 over 3, we end up with 5 yards. It's a rectangle, so the area would be 5 times 4, 20 yards square. And it says for every yard, it costs 18, every yard square is $18.50. So you just multiply it by 20, you end up $370. Okay, let's see. Okay. Let's look at example number 3. Ask us to find a parallelogram in figure 10.40. We have the base, which is 8 centimeter. We have the height, which is 4 centimeter. And the equation for the area of a parallelogram is base times height. So 8 times 4, 32 centimeters square. Okay. Okay. Example number 4, page 561. We want to find an area of a triangle in figure 10.42. The base is 16, the height is 10, base times height divided by 2, 18 meters square. In the figure 10.42, we have the base is 12, but we don't have the height. So what we need to do, you know, what we did is if we draw, in order to find the height, if we continue that side, which is 12 inches, and drop a line at from that top vertex, that top point, then we have, then we can measure, you know, that is 9 inches, that is 15 inches, so the height is 9 inches, the base would be 12 inches, so base times height, 12 times 9 divided by 2 is 54 inches square. The baseline needs to be extended to draw the height. We still use the 12 inches for base in the area formula. The height is given to be 9 inches. That is given to us. Okay? Everything clear? Any question? No, no? Simple. Okay, we continue. Again, these are the, oh, there you go. Oh, here. Let me make this a little bit smaller. Circumference of a circle is pi times the diameter, or pi times 2 times the radius. Example 563. Example 6 on page 563. Again, simple. We have a circle. The diameter is 40 yards, so we take that, multiply by the number pi, 3.14. It's approximately 125.7 yards. The circumference is just a distance around the circle. All right. Let's look at example number 7. How much trim to the nearest tenth of foot is needed to go around the window shown in figure 10.48? The trim covers the 6 bottom of the window and the 2 8-foot sides, but then we have a semicircle at the top. What are we trying to find out? Yes, the circumference of the semicircle. Yeah. So what is the diameter? 6 feet. So we take the diameter times the number pi, but we divide it by 2 because it's a semicircle. Okay. So we get 9.4, and then we just add up and add all these 4 numbers together. We get 31.4. All right. Good. Okay. Area of a circle, we already did that. And, you know, volumes of different shapes. The cube is, you know, think of it, if the area of a square is a square, area of a square, then a volume of a cube, you take one plane and just go all the way to fill that cube. So that's why you have a square times another a to get the volume, a cubed. If for example, look at the rectangular prism. The base is a square, yes? So to find a volume, you multiply AB gives you the area of the base. Now, if I want to find a volume, I have, well, what is the volume? It's just the space. So if I take that base and keep it going all the way till as far as that height lets me, I get the volume. So it's ABH. Now, look at that cylinder. What is the area of a circle? The pi times the pi times, oh no, okay, this is a little bit tricky. No, pi times square root the pi times the diameter to power of 2. Okay, now yeah, that's different. I can't do that. Yeah, d is the diameter, pi is the number pi, and h is the length of the cylinder or the height of the cylinder. You pi times d squared times h divided by 4 gives you the volume of a cylinder. Okay? I was hoping to make it simpler. Let's look at some of these examples. On page 569. Example 1 and 2. We have that volume, we have that shape, that rectangular shape over there, the rectangular solid. All the dimensions are given to us. So we multiply the length 6 times the width 2 times the height 4. You get the volume. Example number 2, it says you want to work on a swimming pool in your yard. The first step is to have a hole dug that is 90 feet long, 60 feet wide, and 6 feet deep. And you have a truck that can carry 10 cubic yard of dirt and charges for each load $12. So how much it will cost you to have all the dirt hauled away. So let's first convert this measurement from feet to yard. So we want to have the yard, so the yard goes to the numerator. We want to get rid of the feet, so the feet goes to the denominator. 90 feet times 1 yard over 3. 1 yard is 3 feet. We get 30 yards. We do the same for the length and the depth. We got all the dimensions converted to yard. We multiply them together, we get 1,200 yard cubits. Now, for the question, the problem also tells us for every 10, the truck can carry 10 cubic yard, okay? So how many times the truck has to come and take away this dirt? You have 120 divided by 10, you get 120 trips. You have 1,200 cubic yard. Each time the truck can take only 10 yard cubic. So you divide 1,200 by 10, you get 120 trips. And for each trip, it costs $12. So you multiply by 12, you get 1,444.
Just to make the hole.
Just to make the hole. Yeah. All right. Let's look at example 3, page 57. Okay. We want to find the volume of this pyramid in San Francisco, Trans-America Tower. Okay. The base of it is in the shape of a square, and its dimension is 52 meters. So 52 times 52, we get 2704 meters square, the area of the base. And the formula for the volume of the prism is base times height divided by 3. We have the height as being given to us, 256 meters times the base, area of the base, and we divide it by 3, we find the volume. Okay, yeah, just if you know the formula, and I will give the formula to you guys. Let's look at example 4 on page 571. Find the volume of a cylinder. Again, we find we have the diameter. It's, yeah, okay. Yeah, this is correct. Maybe, oh, wait a minute. Yeah, that's wrong. That's from NASA. That's wrong. Shouldn't be any 4 here. Yeah.
So if I get it right?
Yeah, it should be diameter.
No.
Diameter. We find the pi times the radius square times the height. You find the area of this circle and multiply by the height. Okay. Sorry about that. So we find the area of the base. We have the diameter. The radius would be half of that. So the radius is 10. The diameter is 20. 10 to the power of 2 times the number pi times 9 yard, which is the height. We get 900 pi yard, or about 2827 yard cubic. Example 5 says, look at figure 10.55. Again, we have the radius of a circle, we have the height. So we plug it into the formula. It's a cone. So the volume is 1/3 of number pi, radius to the power of 2 times h. Yeah, just plug in. That's nothing difficult. You just plug in the numbers. Example 7, for example, find the surface area of a rectangle solid 10.59. Oh, okay. The surface area. So we want all areas for all the surfaces. So, okay, notice we have 2 square and 4 rectangles. Do you follow me?
Yes.
Okay. 5 times 5, 25. Then multiplied by, wait a minute. No. I'm sorry. No, it's it's not a square. It's a rectangle. One side is 5, one side is 3.
Yes.
Yeah. 5 times 3, 15 times 2 would be 30. And then we have one side is 8. One side, those 4 rectangles. The 2 opposite side, one side it has a length of 8, the height of 3, so 3 times 8, 24, again multiplied by 2. The top rectangle has one side of 8, but the other side is 5. So 8 times 5, 40 times 2. You follow me?
Mm-hmm. Yep.
And you add them up, get 158 yards square. Well, that's it. I told you geometry is easier. Any question?
Well, not regarding this lesson.
Okay.
This lesson was like
easy. Okay.
Quite easy, like a reminder of my other math classes. However, my question is from lesson 5.
Lesson 5.
Yes, you had a document with P revealed the first kings.
Oh, okay. Yeah.
I didn't quite understood what it meant.
Okay, let's go there. The number pi. Okay.
Right?
Let me first stop the share because you're not there. Well, actually, I have it right here. Lesson number 5. Pi revealed in the book of First Kings. The following pages in First Kings is often ridiculed by skeptics because it appears to give a wrong answer of the volume pi. The reflecting reading from First King is, it gives you it gives you the dimension of an altar to, or actually a small bat. Okay, it gives you dimension, brim to brim, circumferences, and all that. The object is described is a huge cylinder cast in bronze. But if you see, what's a pi? What's number pi? Pi is circumference divided by diameter. So we can calculate the length between the point C and D if you go to that article. And then we can calculate the length between points C and D in the figure. And pi would be, we have the circumference of 30 divided by CD, so we get the CD approximately about 90.5 cubits. What I'm trying to say here is, I'm not saying that the number pi is actually given, but the dimension there fits the number pi. So the people knew. And what I'm trying to say that in the scripture, when it wants to give the dimension, it says he made a molten sea of 10 cubit from brim to brim. Brim to brim is 10 cubit. Round in a campus, and height thereof was 5 cubit, and a line of 30 cubit compassed it around it. That's the circumference, okay? That 30 here, this is what we have right here when it says, where was it?
30 cubits, yes.
Okay, yeah, and a line of 30 cubits compassed it roundabout. And under the brim of it roundabout, there were knobs where it compassed it, for 10 cubit, compassing the sea roundabout, okay? So what I'm trying basically to say is when they built this little pool, actually, the molten sea or whatever, the pool, we have given the circumference. And we know the number pi is circumference divided by the diameter. Okay, well, we can measure, we have the measurement for CD also. We first let pi equal to 22/7. We get the proportion 22/7 is equal to 30/CD. We get CD is about 9.5. Okay. The 22 cubit that is referring there comes from right here. Okay, where was it? Right here. It says the object described as a huge cylinder cast in bronze holding close to 12,000 gallons of water. Old Testament priests used this basin for washing and ceremonial cleansing. The circumference of the cylinder base circle was 30 cubit, measured with a line or a string, and the diameter of the brim was 10 cubit. The distance from point A to point B in the figure, or AB. By inspection, we notice the diameter of the main body is less than the diameter of the brim. This construction is what skeptics either are ignorant or or ignore. What I'm trying to say is we have AB is equal to 10 cubit. The circumference is equal to 30. So when we plug these numbers, and remember again, the ratio should be the same. we get the line CD equal to 200 to 9.5 qubit approximately. Okay, so there is no error in construction. There is no error in the Bible. Then there is no error in construction of this basin. That's my point.
Yeah, and if you divide 30 divided by 9.5,
you get pi.
Yeah, it gives you similar to pi, 3.1578.
Yeah, yeah.
So, wow.
That's what I mean by number pi, or not me, James Nichol means pi was revealed in First Kings.
Oh, okay. You just had like all those numbers, and I just like I couldn't grasp it.
No, I think you see at the bottom after the scripture, it explains it.
Yes.
Okay.
But I don't know why I read it.
Oh,
like,
no problem. No problem. Okay. Any other question? All right. Well, great. So we can end here. Just please remember, everybody, that you have the final exam for next week, and everything must be turned in by Sunday, July 1st. That's the deadline for the course. All right. Okay, so let's stop right here.